In this session, we're going to take a first look at programming. Before we talk about programming, we really should talk about what computers can do for us. And they really accomplish three tasks for us. They help us control things, they do calculations for us, and they help us to manage data. If we think about control first, it really means three things: being able to make decisions, being able to repeat tasks over and over again, and be able to get information from the outside world into the digital world, and vice versa. In terms of calculations, we can do arithmetic and assign values to things, and we can do evaluation of expressions. And then finally, with respect to data, we can store and retrieve information from various types of storage devices. There are four main reasons that we should learn how to program. The first is control. Being able to control external devices, motors, get information from sensors, and make things do what we want them to do is one of the main reasons that we write computer programs. Another is efficiency. A lot of times we have to repeat tasks many times, and writing a computer program to do that makes much more efficient use of our time. That ties in with repeatability, being able to do things exactly the same way every time we do them, and to be ensured that the results we get are going to be correct. And finally, being able to do things the way we want them to. We can write programs to give us information in exactly the way we want it, to be able to tap into exactly the pieces of data that we want to use, and all kinds of things like that. There are four main skills you're going to need in order to write programs. The first is you have to have a sense of math. You need to understand arithmetic, basic addition, subtraction, multiplication, division, but you also have to have a sense of how things are related to one another. You have to be able to say, in order for this task to be successful, I want this result to be larger than that one. And if it is, I'm going to do this. So we need to be able to compare things and understand how they relate to one another. The second thing you're going to need is to have a sense of logic. And that means being able to look at the tasks that have to be done in order to accomplish a certain thing and put them in the right order so that when you're finished, you have the right information. The next is planning, and that means being able to think through the problem. You have to be able to very clearly specify exactly what's required of the program, do some research to find any information you need to do it properly, and then to think about the best way that that program should be conveyed to your user. Finally, you have to have an understanding of the system that you're using to develop your program. You need to have a sense of what that hardware can do for you, and as well, what the operating system can do for you. With those four skills together, you can make a pretty good programmer. So what exactly is a computer program? All it is a series of instructions that are executed one after the other to accomplish a particular task. It doesn't matter whether you're programming in Java, or C, or Assembler, or any of the other languages that exist out there. As long as you understand what the task is that needs to be done, you'll be able to accomplish it. So instructions are the main element of a program. Using instructions, we can assign values, we can do calculations, we can make decisions, repeat tasks, and even break our tasks into subtasks so that it's a little bit more organized. But in addition to instructions, a program is also going to contain things called directives. And these are instructions that it's going to give directly to the compiler or assembler to help you when you write your code. We'll talk more about this as we start into actual programming. The other thing that's very important when you're writing a program is to comment it. And this is to document the program information. And that's for readers, and it's also for you when you come back to a program later on. And what its main goal is to give extra information to the reader about specific areas of the code. Again, as we start looking at writing actual programs, we'll talk more about comments. Whenever you look at code that's been written by programmers, you're going to see a pretty standard format, and I'm going to ask you to use this format as for all the code that you write in this course. What you'll see first is called a header, and this is general program information. So it identifies the name of the program, what it's for, who wrote it, and when it was written. This section will also identify any changes that are made to it after that program has been released. Next thing you're going to see are things called directives. The first type are interfaces to libraries. So this allows us to link into code that's already written to do things like input and output, be able to do special math functions, things like that. Next thing are defining constants that we'll use in our program. For example, if you want to use pi, you can define that as a constant, and anytime you need to do that, you don't have to put the value in, you refer to the constant by name. The other thing directives can do for us is conditionally include or exclude code, and this is useful for us when we're debugging. Then comes the actual code itself, and each block of code has its own standard format. The first is to declare the variables, and then the instructions required to execute that particular task. A block of code, or a program itself, might have many blocks of code within it, and we'll talk about modularity later on. Once you start looking a little bit closer at the code, you'll see there are three main types of things. There are functional blocks, there are individual instructions, and there are directives and comments. Each of those have their own particular syntax, and each language has its own unique syntax for doing those things. So let's take a look at functional blocks first. So when we look at those blocks, there's going to be a specific way to identify where the starting point is of the program, and this would be called the main code. There are going to be specific ways of breaking a main task into subtasks. Sometimes these are called functions or modules or subroutines or procedures. There are going to be specific ways to make decisions, and there are going to be specific ways to repeat tasks. It doesn't matter what language you're using, you will always find a way to do those four things. In terms of individual instructions, there is always going to be a way to assign a value to a variable. You're going to be able to evaluate expressions. There's going to be a syntax for terminating statements. In other words, the compiler has to know where the end of an instruction is. There has to be a way to call the blocks we talked about up here, and there has to be a way of sharing information between those blocks. Finally, each different language is going to have its own way of defining constants, of linking to libraries, and of excluding or including blocks of code. It's also going to have its own way of defining constants. So when you start a new language, make sure you take a look at the syntax that's involved. Not only do we have syntax, but we have program style and conventions. So in terms of style, we'll talk about things like indentation and leaving white space so the code is readable. Where do we line things up, and how long do we make our lines? All of these things aren't going to make the difference as to whether the program works or not, but they certainly make it more readable. Then there are conventions, and these are things like the way we name things. Some companies will require you to name things a certain way. Other companies, you can write and name your things however you'd like. There are different conventions for commenting things. There are different requirements for simplicity, portability, and how deeply we can nest one block inside another block. So as you progress in your programming career, be aware that different places you work and different people you work for will have different styles and conventions that they would expect you to follow. Regardless of what language you're programming in, there are three main goals for any program. The first is reliability. We want our program to work properly. If it's given valid data, it needs to reliably produce accurate results. The second thing is robustness, and robustness means that if the information the program gets isn't valid, it knows how to deal with it. so your program isn't going to crash if it gets some garbage. The last is maintainability, and this means that the way you write your code is readable by other people and is therefore easy to update, correct, and maintain.